Comprehensive Code YouTube channel. Today, let's solve the problem Leetcode 857, minimum cost to hire K workers. Let's go through the question and then understand the question real quick. So we have n workers. You are given two integers quality and wage, where quality I is the quality of ith worker and wage I the minimum wage expectations for ith worker. We want to hire exactly K workers to form a paid group. To hire a group of K workers, we must pay them according to the following rules. Every worker in the paid group must be paid at least their minimum wage expectation. In the group, each worker pay must be directly proportional to their quality. This means if a worker's quality is double that of another worker in the group, they must be paid as twice as much as other worker. Given integer k, return the least amount of money needed to form a pair group satisfying above conditions. Answer within 10 to the power 5 minus 5 of the actual answer will be accepted. Alright, let's go through this. So we have this question. View overdrive. Okay, we'll see the question clearly. Okay, so let's take this example. Okay, here. So according to the question, we have to form a group of K workers. That means, okay, for example, like if I form a group of first and second worker, for example, like let's say first is A and A has quality of 10 and then B has quality of 70 quality of 20 and C has a quality of 5, right? Now this has wage 70 and then wage is 50 and then wage is 30, right? Now we have to form a group of 2 workers. That means, for example, if I select worker A and worker C, that means the minimum wage I have to pay is, for A it is 70 over 10 and for B it is 30 over 5. Okay, so it has to be proportional to the quantity. That means minimum, if I select worker, if select worker A, worker C, what happens is I have to pay minimum of $7 for this one and $6 for that one. If I select that, then I have to pay the minimum wage. That means I have to at least pay $7 because this is the minimum wage in that group. Okay, so what would be the minimum cost now? So the minimum cost would be, $7 times and the wage and the quantity for A is 10 and then quantity for 5 is C is 5. That means I have to pay proportionate amount. That means proportionate according to the quality. That means for A I have to pay $70 and for B the proportionate, if I have to make proportionate to this minimum wage, I have to multiply this with the quality of C. So basically that gives us 10 plus 7 into 7 no, 10 plus 5 into 7, sorry. So this is 10 plus 5 into 7, that is 105. So if I select that, it will be 105. And then similarly, if I select A and B, A and C, it is 105. If I do same thing for A and B, let's see what happens. So for A and B, so for A it is $7. For B it is 50 divided by 20. That is 50 divided by 20. That is 2.5. $2.5. I have to pay at least $7. That means if I select A and B, I have to do that. That means $7 times the quantity is 20 plus, if I select A and B, that means 10 plus 20. If I do that, 30 into 7, that is 210. And similarly, like if I selected A, B, I selected A, C. Now if I select B and C, what will be the minimum wage? Try to think. So for B, we have $2.5. We already calculated. This is for B and C. Okay, so for C it is 30 divided by 5, that is 6, right? $6. So we have to pay a minimum of $6, and then we have to make it proportional with the quality we have. That means 5 for C and 20 for B. That gives us 6 times 25, that is 150. Among these three, this is the minimum, so we return 105. So if we see the example, we return 105 for this one. Okay, now think about it. I think some intuition comes up now. The first thing, we have to choose greedily. Greedily what? We have to choose greedily the lowest ratio. And then if we choose the lowest ratio greedily, and then also maintain quantity, for what quantity we are doing that. If we maintain that in a sorted order, then what we can do is, for example, like what I'm saying here is, what if we have something like this? So a data structure which holds the ratio of weights by the ratio of weights by quality, and then it also stores quality maybe in a tuple. Okay, and then we sort this. Okay, we have this type of data structure, and we sort this based on the ratio of weights over quantity. And then if we sort that, and then we iterate through this sorted list, and what we do is as we iterate, what we will do here is we'll maintain a heap, maximum heap, where the maximum quantity will be at the top, and then we will accumulate the quantity as we go, and then if we exceed k workers, that means we have to remove the top quantity worker so that the waste is minimized. And if it is equal to k, that means like we find a minimum and we update the minimum with the current ratio that we have and the total quantity we get till now. So I think it doesn't make sense right now when I'm talking, but let's go through the code. I think it'll be very clear when we write the code. With that, let's start writing the code. As I said, in the beginning we have to maintain all. So we have to maintain a list of the ratio of ways to quantity. So let's initialize some variables first. Length of quantity, quality, equal to length of quality, and then we also track minimum cost, which will be float infinity at the beginning, and then quality till now it is, let's initialize 0 at the beginning, and then we also maintain ways quality ratio. Okay, so now we iterate over the quantity, the length of quantity, I in range, length of quantity, that means like n quantity. And then what we're saying was ways quantity ratio dot append. We were appending the ways as ith index, and then the quality at ith index. So this will give us a ratio, but we also want to store the quantity so that we can reference that quantity later. Okay. So now, as I said, we have to sort this based on the ratio. We put the minimum ratio at the beginning. So we choose greedily. Ways ratio is sorted ways ratio, and key is our lambda x, and then x 0, because we want to sort it by this ratio. Once we have this sorted, now what we can do is, as I said, we'll loop through I in range and quantity, and we also maintain our high quantity workers, quality workers. Go to that, and then we iterate over that, and we'll find the ratio. The ratio is and then the quantity, worker quantity, that is ways quality ratio I, and then okay, that is the ratio that we have, ratio and worker quality. And then what we are saying here is we will add as we go. Okay, so now we'll push this heap push. Let's import from collections, import heap from heap queue, import heap pop, heap push. Okay, so now heap pop, heap push our high quality workers, and what we want to push here is the negative of W quantity. Okay, we want to do that. Now what we have to do is, as I said, if k is greater than, or length of our high quality workers is greater than k, we just want to quantity till now, we just want to subtract heap pop high quality workers. So we just want to subtract that because we have added negative. So it's it negates, it subtracts the top quantity worker with the value that we have in the quantity till now. But if the length of our high quality workers is equal to k, that means we have to update the minimum cost now. Means minimum of minimum cost, and then quantity till now times the ratio we have. So at last we just return the minimum cost. So let's run through one example. So if we have solution, go to solution, and then let's take one example that we have here. Okay, print solution dot that, and then we are passing quality and then ways and then k. Okay, let's see. Okay, quality, ways, and k. Let's run this code. As you can see, we can see 105. I think that is pretty much it. Let's talk about the time complexity and space complexity. So the time complexity for this algorithm would be, let's go through here. So we are doing sorting for the quantity list. That means we are doing n log n here, and then also for here we are doing for quantity. What we are doing is we are pushing that means also doing n log k. So that will be the time complexity. And space complexity, would be we are storing the ways quantity ratio, and also we are maintaining a heap of size k. That means we have space complexity of order of n plus k. With that, let's run this in Leetcode to make sure like it passes all the test cases. Let's see. As you can see, it runs everything, and let's submit it. As you can see, it is accepted, and it's pretty efficient. Thank you for watching this. If you have some confusions, just comment down in the comment section below. And if you have not subscribed in my channel yet, please do subscribe. It helps me a lot. Thank you.